The next set of information for the periodic table is looking at the organization of elements. The first thing that we should recognize, and we have stated before, the periodic table is arranged by the atomic number. So that is the governing organization of the periodic table is atomic number. We have here the families in the periodic table, which are the vertical columns, and it is based on properties of the elements, so we also use the word group. In class, we will color the periodic table, or if you choose to do it ahead of time, it is provided in your notes, room to do that. So the periodic table, we have 18 columns, and we also have the little segment down at the bottom. So groups or families are the elements in the vertical columns that share similar chemical properties, and that is based on their valence electrons. So once again, groups or families. They are numbered from 1 to 18, from left to right, and then we also have that section on the bottom that is also considered a group or family. Our first family is alkali metals. The name comes from al-kali for ashes. Ashes in water form slippery substances that cuts grease. Also thought of soap, so alkaline ashes contain compounds from group 1. So very useful in soap making, and if you think about the slippery feeling, we are thinking of bases, so these guys often make bases. Alkali metals are known as group 1A, so that's Roman numeral 1, and then A for the representative elements, or simply group 1. They are considered the S section of the periodic table, and right now that doesn't mean a lot, but we will be talking about electron configurations, and that S will be very important. They are very reactive metals. They have one valence electron, and they make +1 cations. Now notice hydrogen is in that column, and we will discuss him later. The alkaline earth metals form alkaline solutions. They are fire resistant, called earth substances by medieval alchemists. So a little history on those. They are in group Roman numeral 2A, or just simply group 2. They are also part of the S section of the periodic table. They are reactive metals, but not as reactive as the alkali metals. They have 2 valence electrons. Groups 3 through 12 are the transition metals, so they're that center segment of the periodic table. They are known as the B column, so after the Roman numerals you will see the letter B. They are known as the D section of the periodic table. The number of valence electrons in here equals the Roman numeral above that group. They are called transition metals because when they form ions, they can vary. So transition means change, and these guys can change depending on what their circumstances are. They can form different types of ions. Another piece of information with transition metals, when they make salts, they often have color. So these guys do not form alkaline solutions. They are harder and less reactive with water than alkali metals. So let's think about it. We use copper, or have been using copper, for our water pipelines because they don't rust very quickly, unlike some of the other metals, and we will look at some of those. So they are used for structural purposes. So they're part of those alloys. They contain some of the best known and important metals. We have iron, nickel, chromium, and then our favorites, silver and gold, and we can't forget platinum too, PT. So jewelry and some other fine items come from those metals. There are some other families that don't have super specific names. So column 13, or group 13, is Roman numeral 3A. So these are all also representative families. So they all have the A after them. They do have 3 valence electrons and create plus 3 ions. Group 14 or 4A has 4 valence electrons and creates plus or minus 4 ions. Keep in mind that the magic number is 8, and we'll learn about that with bonding, but magic number is 8, and it's neither easier or harder to gain or lose 4 ions. It just depends on what the element is and what the other element is near it on how it's going to form or if it will form. Group 15 or group 5A has 5 valence electrons. It will create negative 3 ions, so they are gaining electrons, and they're gaining 3 to make that magic number of 8. Group 16 or 6A has 6 valence electrons, so they create minus 2 ions. All of the families here, group 13, 14, 15, and 16, are considered part of the P section of the periodic table, and they also contain transition metals on their lower end of their column. We'll look at that when we see the metals periodic table and some of the other images of periodic tables, that there is some odd stuff going on there. They are not solid families like the other families as we think of them. But they do all have in common in their column the number of valence electrons. One of our favorite families are the halogens. They are salt forming. They form a lot of compounds that we do know as salt. So let's think of our favorite guy, sodium chloride, our wonderful table salt. So there's our chlorine in our halogen family. These guys are group 17 or Roman numeral 7A elements. They are also representative elements. They are part of that P section. They are very reactive nonmetals, where column 1 was very reactive metals. They do have 7 valence electrons, and they form the minus 1 anions, so they are gaining 1 electron. Our last family in the main part of the periodic table are the noble gases. They are the most unreactive group. We did say that they do not mix with the commoners, so if we think about the nobles in other countries, they're not out hanging out in the streets with the regular everyday people, so they are noble and they are not interacting with the commoners or the regular elements. These guys are column 18 or group Roman numeral 8A. They are the P section of the periodic table. They are highly unreactive, so you're going to not find too many compounds that have these elements in them. They have 8 valence electrons, and in the grand scheme of elements, all the other elements want to be like them, so they want to get their configuration. We have that little section at the bottom of the periodic table. Those are known as the inner transition metals. There is that name, transuranic metals, so there's 2 different ways you can look at them. They have no group number, but each row has a similar chemical properties that they are their own groups, so each little column is unique. Within that series, we have the lanthanides, which is period 6. There are 14 metals after lanthanum, 57. They are very difficult to purify because of similar properties, and some are used in making laptop screens, so some of those chemicals are in our computers. The actinide series is period 7, so we haven't talked about periods, so we're talking about left to right. There are 14 metals also found after actinum, number 89. The most famous is uranium and plutonium. So I said we'd talk about hydrogen, and hydrogen is placed in group 1, even though it is a gas. It is not a metal. It is located there because of the valence electrons, not because of its properties. And we've used the word valence electrons, and in our atom history, we did talk about those also with the Bohr model, that they are the electrons in the outermost energy or shell. So elements in a group or column have similar properties because they have the same number of valence electrons. So the valence electrons do determine on how reactive an element is. So the key here is valence electrons relate to the families or groups, also known as columns, and we can determine those by looking at the Roman numerals at the top. Here we have the periods. We did mention the periods earlier. That little section at the bottom I did not color in. Those are the lanthanides and actinides, so they're technically families there. And they do insert within the periodic table. It just makes it really hard to print a periodic table on a nice piece of paper if you push that in there. So by removing it, it just keeps that nice uniformity. So our periods are going from left to right. And notice that each row has a different color. So periods are based on atomic number, and they do have that regular change that occurs in patterns in certain intervals. So we're back to that whole process of Newlands. With periods, we are not looking at things that are alike. So as we go left to right, they can change and have nothing to do with the guy beside them. So I kind of think about our neighborhoods. Within our homes, we have different floors or different levels, so we're going vertical up and down, and we are all very similar. Believe it or not, you are a lot like your parents, and they are a lot like their parents, and your siblings, you're all, you do have a lot of characteristics that are the same. You're a family. But if we look at our neighbor's house, we're not like our neighbors. Now, I do understand some of you may live near your grandparents, but you're not the normal case. So let's think about our stereotypical families. They're not living beside their neighbors, and neighbors are not like you. They have completely different properties, and they have different characteristics or family traditions than what you have within your house. So your house goes up and down, and that is your family, and then your neighbors go left and right. So those are the periods. I also think about when you're writing a sentence, you write from left to right, and the most common punctuation is the period. So period numbers equal the number of energy levels within those elements that they need. So period 1 has just 2 elements, and period 2 and 3, if we count those across, there's 8 elements. Period 4 and 5 have 18 elements, and period 6 has 32 elements. Doesn't that sound a lot like those shell numbers on how many electrons they can hold? So looking at that, the first element of each period has only 1 electron in its outermost shell. So period 1, H, we're looking at the K shell. Period 2 is lithium, and he's starting to utilize that L shell, so our second energy level. And period 3, sodium, is going to our third energy level, or the M shell. And period 4 has 1 electron, so he's in the fourth energy level in the N shell. And it goes on from there. So there's our shells from the Bohr model, and how many electrons that fit in them. We can count the blocks across the periodic table. So we have those cute little hints to help us out, and now we can kind of see how Bohr's model relates to the periodic table. The first element in a period is usually a very active solid, and then the last element in the period is an inactive gas. But keep in mind that column 17 are very active nonmetals. So the activity in column 1 and column 17 is very high, and then in between we kind of lose that activity. But at the very end we have our non-active gases, our noble gases. So here's another look at the periodic table, showing the columns a little bit, but now we're also showing overlaps in the metals where the metalloids are in blue, and we have that orange section under the metalloids. Not really sure what they're trying to show there. They are metals, so but they're not transition metals, so they did change the color there. And then our representative metals are in the orange on the left. So they're trying to say that those guys are also representative metals in that little funky shape underneath metalloids, but some of those are transition metals too. So not all color-coded periodic tables represent exactly what's going on, but we just try to help out. One of our last things we want to look at is periodic table trends, and we will do that in the next video.